Hello, my name is Zanititesh Mehta, and today I'll be presenting the Dsip Ia project with my fellow presenters Yash Salunke and Parth Sankoi. So, the flow of implementation and the approach that we have selected in the project implementation is as follows. Reading an image of either grayscale or RGB image. So basically, we read an image, it will be either in the grayscale or in the RGB format. Second point is that to convert the image into a grayscale if the image is in RGB. So we convert the image into grayscale if the image is in the format of RGB. Decomposition of images using wavelets for the level N. So we'll do the decomposition using wavelets for the level N of the images. Decomposition of images using wavelets for the level N. So we'll do the decomposition using wavelets for the level N of the images. Selecting and assigning a wavelet for compression. So we will select a wavelet and it will assign it for the purpose of compression. And the fifth point is generating threshold coefficients using bridge method strategy. So we'll be using this strategy to generate a threshold coefficients to get the specific output. So I'll request Yash Salunke to continue from here.
Moving on forward, the next step will be performing the image compression using wavelengths. So now we'll give a image and then perform image compression as if the image file size is more than 5 or 6 MB, we need to compress it. Then we will be doing computation and displaying the results such as compressed image. Next step will be performing the image compression using wavelengths. So now we'll give a image and then perform image compression as if the image file size is more than 5 or 6 MB, we need to compress it. Then we will be doing computation and displaying the results such as compressed image, retained energy, and zero coefficients. Then the decompression, we will decompressing the image based on the wavelet decomposition structure. And after we decompress the image, we will plot the reconstructed image and then we will try to compute it and display it again. So the next step will be computing and displaying the size of the original image, the compressed image, and then the decompressed image. Moving forward to Parth.
Parth, I'll
So
request you
now
to
I'll
continue.
discuss about the results and the analysis. So the first result is the main goal of this system is to maintain the quality of image after the compression using wavelet algorithm. So wavelet algorithm prevents like deterioration of the quality of the image that we are using in this experiment and while analyzing our project. So the next result is the image quality is one of those concepts that is greater than the sum of its parts, and normally the goals of image compression is to produce compressed image of the highest quality. So we don't just have to reduce the size of the image, we also have to maintain the quality of image so that it doesn't get blurred or any isn't affecting its clarity, and while also reducing the size of the image. Then the next result is from a reconstructed image that we just made. It indicates that the quality of original image and compressed image are similar. So the reconstructed image is having the original image and the compressed image of the same clarity, and it is the best overall trade-off between image quality and load time for the image compression. So the image compression's load time is also trade-off between image quality and load time for the image compression. So the image compression's load time is also balanced with the image quality. Now the next result is reconstructed image it like the reconstructed image clearly represents that these images are with no perceptible distortion, even though it is compressed. So there is no distortion in the image, in the compressed image, and with levels of 1.5 of decomposition and compression. So 1.5 level prevents the deterioration of the quality of the image. There is no image data that is lost during higher compression. So the image data remains contact, and even while in the higher levels of compression, the image quality is retained. Now we move on to the next slide. So as we see, these are the three images that we are using for the analysis. The first one is the input image, wherein you can see a high definition clarity image, but with a higher size. Now we compress the image firstly to a lower size of image, so that we see a lot of distortion and quality deterioration in the image. But then we have to reconstruct the image into the same size but with higher definition, and to match it with the quality of the image, input image we have used. So the reconstructed image, as you see, is very much similar to the original image in terms of quality, but the size of the image would still remain as same as the compressed image. Now we move on to the next slide. I request Yes Salunke to continue.
Now, to conclude our PPT, what we learned from the
I request Yes Salunke to continue.
now to conclude our PPT, what we learned from the analysis done, it is clearly seen that the use of half wavelet algorithm in compressing the image can maintain the quality of image. It produces high compression performance and minimize the amount of data so that it can be transmitting effectively. It is also noted here that for JPG images, it can reduce almost half of the original image by using HAAR wavelet algorithm. So, Zenith, if you explain about the documentation.
So let's look at the documentation. So if you all have any doubts, you can see we have discussed all the possible algorithms that we can use over here. And we have also introduced different algorithms that we can use. This is the methodology, and we have discussed in detail about the presentation over here. This is the entire diagrammatic flow of the presentation. This is the block diagram, result and analysis in detail, much more information about the results and comparison of JPG and PNG images. So this is